Appearing in the second episode of the Netflix speculative astrobiology series Alien Worlds, the planet Janus is a tidally locked rocky world trapped between a searing desert on one side and a frozen wasteland on the other. In between lies a ring of habitability bathed in perpetual twilight in which all of the world's life survives. The planet is a dry terrestrial, 90% the size and mass of Earth. This gives it a surface gravity 11% higher than Earth's and an abnormally high mean density of 6.8 grams per cubic centimeter. Such a density suggests that Janus is a high metal content world with a large core and comparatively thin mantle. Janus orbits its red star at a distance of 0.18 astronomical units, with a period of approximately 48.5 Earth days. There is, of course, no such thing as a local day on Janus, as the planet is tidally locked and keeps one side perpetually facing its sun. Due to the planet's orbital distance, its day side receives approximately 43% less energy from its sun than Earth does. Even so, temperatures on the day side are reported to reach 65 degrees Celsius, while temperatures on its dark side can drop to negative 50 degrees. The system star is a main-sequence red dwarf with a reported effective temperature of approximately 3,500 Kelvin and a mass of 0.33 solar masses. This gives it a luminosity around 2% that of the Sun and makes it likely to be a spectral type M3 star. From the surface of Janus, its red sun has an angular diameter of 1.0958 degrees, making it appear just over 2 times larger than the Sun appears in Earth's sky. So clearly the view seen in the documentary's various establishing shots is greatly exaggerated, though the scenes showing the Sun from the surface of Janus are pretty accurate. One of the many problems facing the potential habitability of erythrogean planets, that is, planets like Janus that orbit red dwarf stars, is the so-called cold trap scenario. This happens when water is evaporated by the unyielding heat of the planet's day side and driven to its night side by strong convection currents in the atmosphere, where it then condenses, rains out, and freezes onto the surface. This continues until all of the planet's water is locked up on the planet's night side in deep glaciers that will never melt, leaving the entire planet a lifeless desert. One of the ways scientists propose a planet could avoid this is by having a thick atmosphere and/or a global ocean, both of which could distribute the day side's heat around the planet and potentially prevent the night side from reaching temperatures low enough to initiate a cold trap scenario. However, Janus appears to have neither of these. It certainly doesn't have a global ocean, and from the visuals seen in the documentary, its atmosphere doesn't look thick enough to do the job. And this assertion seems to be confirmed by the documentary, which shows the planet's night side as a vast landscape covered in snow and ice, and labeled as a frozen shadowland. The documentary hints at the presence of a water cycle on Janus, saying,
"Freezing meltwater flows from the cold side,"
but then neglects to elaborate on the mechanism by which this occurs. Water usually flows downhill, and there is no reason that the night side of the planet would have a higher elevation than the day side. So such an event could only be a local phenomena that happens in select locations along the planet's terminator, and not a process of the global water cycle, or evidence of the existence of such. The documentary goes on to claim that volcanism provides heat to the planet's night side, melting the ice and creating geysers and geothermal pools that support various forms of life. Yet, once again, this can only be the case in select locations adjacent to the planet's terminator. While volcanism can raise the temperature of the land and air directly above it, this warming remains localized to within just a few hundred meters of the volcanic breach. To warm the planet's night side enough to avoid a cold trap scenario would require a significant amount of the planet's crust to be molten. So how does Janus measure up against real exoplanets? The planet's mass, size, surface gravity, and mean density are all within realistic bounds, and the geology of the planet's surface features seems appropriate for such a world. So, plus 1 point. Likewise, the planet's orbital distance and period are consistent with a tidally locked planet orbiting a red dwarf star. Plus 1 point. No data is given for the planet's atmospheric composition nor pressure, so it's not possible to corroborate its reported temperature range. Furthermore, it does not appear to be equipped with the environmental features necessary to avoid a catastrophic cold trap scenario, so -1 point. Although Janus does not have any moons, this is commonplace among terrestrial planets in general and consistent with a planet orbiting so close to its parent star. +1 point. The properties of the system's star are very accurate and consistent with a star of its specified spectral type and class. +1 point. With a total of 3 points, the planet Janus from Alien Worlds receives a B grade. Overall, the creators of this planet did a good job building it, but they picked a very difficult type of world to build. Erythrogean planets are enigmatic objects with a number of potentially fatal flaws. It may be that such planets aren't even capable of being habitable, or it may be that they are the most common type of habitable planet in the universe. Modern planetary science isn't quite sure yet, so authors need to do extra research and be extra careful when building one. Thank you for joining me in my analysis of the planet Janus. From here, I'll be charting a course taking me far away from this star's red glow and toward yet another strange alien world. I hope to see you there.